Hello, celestial dreamers, and welcome once again to Bedtime Universe. Tonight, we journey not to a distant nebula or a forgotten star, but to a moment in our very recent past. A moment suspended between profound discovery and profound silence. It is a story of a traveler from an unknown shore, an object that journeyed for eons through the interstellar dark, only to arrive at our doorstep at the most peculiar of times. This is a tale of a government that went dark, a space agency that fell silent, and an alien comet that kept its secrets as the world watched and waited in a state of suspended animation. So, find a comfortable position, let the noise of your day recede like a distant tide, and allow your mind to drift. Tonight, we explore the enigma of 3I divided by Atlas, and the unnerving coincidence that turned a scientific marvel into a modern mystery. Our story begins on a date now etched into the memory of a select few astronomers and space enthusiasts. October 1st, 2025. It began not with a bang, but with a quiet, administrative whimper. Across the United States, a budget impasse in Washington, D.C. triggered a full government shutdown. For most federal agencies, this meant furlough notices, locked doors, and a frustrating pause on public services. But for the National Aeronautics and Space Administration, NASA, it meant something more profound. It meant switching off the lights on humanity's window to the universe. At the Jet Propulsion Laboratory in Pasadena, California, Dr. Elias Vance watched as the sprawling campus emptied out. He was a mission planner, a man whose life was dictated by orbital mechanics and celestial timetables. His normally vibrant control room, a cathedral of data streams and cosmic chatter, was now hushed, populated only by a skeleton crew designated as essential personnel. Their job was not discovery, but preservation, to protect life and property, to keep the multi-billion-dollar spacecraft scattered across the solar system from falling silent forever. The International Space Station would continue to orbit, its crew safe. The Mars Reconnaissance Orbiter would keep flying, but the flow of information, the very lifeblood of science and public engagement, was being severed at the source. The main NASA.gov website was replaced with a stark closure notice. The endless stream of breathtaking images on social media ceased. NASA TV went off the air. A procedural silence, mandated by the arcane articles of the Anti-Deficiency Act, had descended. Under normal circumstances, this would have been a source of immense professional frustration. But these were not normal circumstances. For on this exact day, at this precise moment in the grand cosmic ballet, an object of immense scientific importance was gliding into the most opportune observation window humanity had ever been granted. Its name was 3I divided by Atlas. The 3I designated it as the third confirmed interstellar object ever detected. The first, 1I Oumuamua in 2017, had been a bizarre, cigar-shaped enigma that left scientists debating its nature for years. The second, 2I divided by Borisov in 2019, had been more comfortingly familiar, behaving much like a typical comet from our own Oort cloud. 3I divided by Atlas, discovered just 3 months prior on July 1st, 2025, was the next chapter, a new data point in a field of study so young it barely had a textbook. It was following a hyperbolic trajectory, the mathematical signature of an unbound object, a cosmic tourist just passing through. It was a physical fragment of another star system, a time capsule carrying the chemical fingerprints of its alien birthplace, and it was heading for a close encounter, not with Earth, but with Mars. The orbital geometry was a gift from the heavens. Between October 1st and October 7th, 3I divided by Atlas would make its closest approach to the red planet, passing within a mere 30 million kilometers. From Earth, the comet was difficult to see during this period. positioned at a low solar elongation, meaning it was lost in the sun's glare. Our ground-based telescopes were effectively blinded, but our robotic emissaries orbiting Mars had a front-row seat. They could observe the comet from a perfect side-on angle, unhindered by the sunday. This was the plan, a coordinated, multi-agency campaign. While NASA's assets were formidable, the European Space Agency, ESA, had been exceptionally transparent about their intentions. Their Mars Express and ExoMars Trace Gas Orbiter spacecraft were prepped and ready. Their mission, scientists had given interviews, their excitement palpable. They aimed to study the comet's coma, measure its outgassing activity, and hopefully capture spectra that could reveal its composition. The world of planetary science was buzzing. Then, the lights went out. As ESA's spacecraft began their meticulously planned observations, NASA's public-facing infrastructure went completely dark. Elias Vance and his essential colleagues could ensure the Mars Reconnaissance Orbiter, MRO, and its powerful high-rise camera remained operational, but they were legally prohibited from engaging in any activity not directly related to protecting the spacecraft. Science planning was a gray area. Public data release was out of the question. A veil of silence was drawn over NASA's entire Mars fleet. The contrast was stark and immediate. ESA continued to issue updates, their scientists speaking to media outlets about the ongoing campaign. From America, there was nothing. This asymmetry created an information vacuum, and, as is always the case, speculation rushed in to fill it. The internet, a place where curiosity and paranoia dance a tangled tango, began to buzz. Threads on Reddit and deep dive videos on YouTube started connecting the dots. Isn't the timing a little too perfect? One user asked. NASA discovers something huge with 3I divided by Atlas and uses the shutdown as the perfect cover to classify it. The whispers grew into a roar. Claims began to surface, unverified but compelling. Some swore they saw raw image files from MRO briefly appear on a public server before being scrubbed. Others, examining pre-shutdown data, claimed to find evidence of unscheduled maneuvers, tiny burns from the comet that couldn't be explained by natural outgassing. The most tantalizing rumor centered on the comet's composition. Leaked whispers from anonymous sources hinted at preliminary spectra showing unusually strong nickel emission lines. Nickel, a metal, is not unheard of in comets, but the reported abundance was anomalous. This, combined with early mass estimates from Hubble data that were on the high end of the uncertainty range, painted a picture of an object that was far denser than a typical ball of ice and rock, a metallic monster, as one headline sensationally dubbed it. From his quieted station, Elias could only watch the storm of speculation unfold, a helpless bystander to the narrative being woven in the absence of fact. He knew the mundane truth. He had read NASA's continuity of operations plan. He understood the legal constraints, but he also understood the optics. The silence looked like concealment. The timing looked like a conspiracy. To understand the mystery, one must understand the competing hypotheses that bloomed in that quiet October week. They ranged from the mundane to the truly extraordinary. Hypothesis 1, the most likely and the most boring, was that of bureaucratic coincidence. The shutdown was a simple, unfortunate alignment of political failure and celestial mechanics. NASA's silence was procedural, not intentional. Any data collected was simply sitting in a queue, waiting for the shutdown to end and for furloughed scientists to return to their desks to process it. Nothing was hidden. It was just delayed. This was the explanation favored by Occam's razor. The simplest answer is often the correct one. Hypothesis 2 was the massive metallic core. This theory latched onto the nickel rumors and the ambiguous mass estimates. It proposed that 3I divided by Atlas was not a comet in the traditional sense, but a fragment of the iron-nickel core of a shattered exoplanet or large planetesimal. Such objects, called differentiated bodies, have heavy metals sink to their center. A catastrophic impact in its home system could have blasted a piece of this core into interstellar space. This would make 3 I divided by Atlas a scientific treasure trove, a solid piece of the deep interior of an alien world. The implications for planetary formation and for future resource mining were immense. Hypothesis 3 was the shadow that had lingered ever since Oumuamua, the engineered or technological artifact. This was the most sensational theory, suggesting 3 I divided by Atlas was not natural at all. It could be an active probe, a derelict spacecraft, or a piece of alien megastructure. Proponents of this idea, led by vocal astronomers like Avi Loeb, who had championed the same possibility for Oumuamua, argued that we must remain open to the possibility. Any non-gravitational acceleration not clearly linked to cometary outgassing, any structured light curve, or, the ultimate smoking gun, any coherent radio signals, would be evidence. No such evidence had been confirmed, but in the information vacuum, its absence was not enough to quell the speculation. Then came the deeper, darker theories. Hypothesis 4 suggested a third-party intervention. Could a nation with secret advanced space capabilities, the US, China, or Russia, have used the Mars window to conduct a covert rendezvous or inspection mission? It sounded like science fiction, but the theorists argued that a metal-rich object of unknown origin would be of immense national security interest. The shutdown would provide the perfect cover for such a clandestine operation. This bled into Hypothesis 5, black-budget data capture. This theory proposed that even if no physical intervention occurred, military and intelligence assets like the National Reconnaissance Office's spy satellites or the Space Force's advanced tracking radar had observed 3 I, divided by Atlas. Their data, which would be far more detailed than anything NASA or ESA could produce, would be instantly classified. The public would never see it. The silence from NASA wasn't just a consequence of the shutdown. It was part of a coordinated effort to keep the real data under wraps. Finally, there was a more grounded scientific possibility. Hypothesis 6, a planetary interaction event. This theory suggested that the close pass by Mars itself triggered a transient event. Perhaps a gust of solar wind, interacting with Mars's weak magnetosphere, simultaneously hit the comet, causing a temporary, dramatic brightening or an outburst of gas that was misinterpreted by early observers. This would be a fascinating scientific discovery, an observable interaction between a comet and a planetary environment, but entirely natural. For weeks, these 6 narratives battled for dominance in the public sphere. Elias Vance and thousands of other scientists could only wait. The shutdown dragged on. The comet passed its perihelion, its closest approach to the Sun, in late October, and then swung behind it, entering a period of solar conjunction where it was completely invisible from Earth. The dead zone of the Mars window was followed by a natural blackout. Finally, in mid-November, the political stalemate broke. Funding was restored. NASA's websites flickered back to life. Furloughed employees returned, blinking in the sudden light, to face a mountain of backlogged work. For Elias, the real work could now begin. It was a process he called data rescue. He and his team began the painstaking task of retrieving, processing, and calibrating the data collected by MRO and other assets during the shutdown. Simultaneously, they began to coordinate with their counterparts at ESA, who were already well into their own analysis. The first pieces of the puzzle began to click into place. ESA's data from Mars Express was clean and comprehensive. It showed a clearly active comet with a coma and tail. The spectroscopy did confirm the presence of nickel, but at levels that, while high, were not entirely outside the realm of possibility for a comet formed in a metal-rich protoplanetary disk. There were no sudden, inexplicable maneuvers. The light curve was consistent with an irregularly shaped, tumbling nucleus, not a controlled, structured object. Then came NASA's data. After weeks of processing, the first images from MRO were released. They were not the crystal-clear, revelatory pictures the conspiracy theorists had hoped for. As predicted by the laws of optics, at a distance of 30 million kilometers, 3I divided by Atlas was little more than a fuzzy, overexposed blob at the center of a star field. The valuable data was in the photometry, the precise measurement of its brightness, not in its shape. And that data, when cross-referenced with ESA's, matched perfectly. Both agencies had seen the same thing: a comet, behaving like a comet. The final piece of the puzzle arrived in late November and December. As 3I divided by Atlas emerged from behind the Sun, a global network of ground-based observatories, from professionals in Chile to amateurs in their backyards, locked onto it. Its trajectory was plotted with exquisite precision. The orbit fit the model of a hyperbolic path, influenced by a slight but entirely normal, non-gravitational force, consistent with outgassing of volatile ices like water and carbon monoxide. There was no evidence of a high-density, metallic core deflecting its path. Radio telescopes, including a concerted campaign by the SETI Institute, scanned it relentlessly. They found only the quiet hiss of the cosmos. The grand mystery of 3I divided by Atlas resolved itself not with a shocking revelation, but with the steady, quiet accumulation of collaborative, verifiable data. The mundane explanation, Hypothesis 1, proved to be the correct one. The shutdown had been a deeply frustrating, scientifically damaging, but ultimately simple coincidence. The silence was not a cover-up. It was a consequence of policy. The comet was not an alien messenger. It was a fascinating but natural piece of another world. For Elias Vance, the experience left a lasting mark. The story of 3I divided by Atlas became a powerful lesson. It revealed the fragility of our scientific infrastructure and the critical need for transparency. In an age of rampant misinformation, silence from trusted institutions is no longer a neutral act. It is an invitation for the darkest, most compelling fictions to take root. The incident spurred a quiet but significant policy review within NASA about how to maintain a minimal, essential line of public communication during future shutdowns. 3I divided by Atlas continued its journey, fading back into the interstellar darkness from which it came. Its brief, chaotic visit to our solar system complete. It left no smoking gun, no alien message, but it left a legacy, a reminder that the search for truth is a global, collaborative effort, and that sometimes the greatest mysteries are not hidden in the stars, but in the human systems we build to observe them. And so, the traveler departed, leaving us with more data, more questions, and a profound lesson in the importance of an open dialogue with the cosmos. The mystery of 3I divided by Atlas was not one of alien technology, but of human communication. It reminds us that in the quest for knowledge, the greatest obstacle is sometimes not the vast distance between stars, but the walls we build between ourselves. A humbling thought to carry with you into your dreams. Thank you for joining us on this journey through the quiet corridors of space and policy. We hope this story has given you something to ponder as you drift off to sleep. Until our next celestial story, from all of us here at Bedtime Universe, keep your eyes on the stars and your minds open to wonder. Sleep well, and may your dreams be as vast as the universe itself. This next story unfolds like a slow river of light, flowing through the galaxy and straight into your imagination. It is not rushed. It does not demand, only offers its calm, like the night sky itself. Begin by picturing yourself under a truly dark sky, no city glow, no neon signs, just you, the quiet earth beneath your back, and above you a pale river of light. That soft ribbon is the plane of our Milky Way, the view from inside our own spiral home. We are looking edge-on through a grand disk of stars, hundreds of billions of them, each one burning in perfect, silent persistence. If the night is clear, you'll notice mottled patches and dim lanes where dust clouds drift, sculpting the light into curtains and folds. That hazy beauty is not far away. It's our neighborhood, our address in the cosmos, and lying beneath it you can almost feel the galaxy breathe. Let your attention rest on a single star. It looks steady to your eye, a silver pin, yet that small light is a sun, with weight and heat and years enough to send you its glow across gulfs so wide they blur into time. The light you see left that sun long ago. It traveled quietly, never hurried, slipping through space until, tonight, it touches you. In this moment, you are reading an ancient postcard. Whatever your day held, messages, tasks, worries, none of them can chase light across years. You are safe here, held inside an old, patient story. Now, soften your gaze. The familiar patterns return: Orion rising in the cool months, Cassiopeia poised like a simple crown, the Big Dipper pouring toward the horizon. We call them constellations, but they're more like gentle chapters in a sky-wide book. Their shapes are not fixed. Over immense spans of time, stars drift with unhurried grace, rewriting the outlines of hunters and queens. The sky, you know, is a snapshot in a long, serene dance. Even change, on these scales, is tranquil. Let's wander inward, between the stars, into the interstellar medium space that is not empty but filled with thin veils of gas and dust. Imagine clouds so vast that a beam of light crosses them for years, and yet so delicate that a teaspoon of air on Earth holds more particles than a kilometer of that cloud. In these gauzy nurseries, gravity does its quiet work, tugging gently, gathering specks into clumps, clumps into knots, knots into hot, shining beads. A star is born not with a shout, but with patient accumulation, one grain, then another, until fire begins and a new light joins the river. Out at the edge of your vision, a blur blooms. The Andromeda galaxy, our great neighbor. Its glow set out toward us when early humans were first finding their stride. Andromeda is huge, 1 trillion stars washing together into that single soft smudge. You can stretch out a hand and, with a fingertip, cover an entire island of suns. And in that gesture, you learn something gentle and important. The universe is vast, yes, but it is also reachable to the heart. Even a faint smear of light can carry the weight of millions of worlds and arrive as a whisper that says, "You belong here." Every so often the night sprinkles a brief spark, one thin line, then gone. A meteor is often a grain of dust surrendering to our sky, brushing the air so quickly that it burns, writing a single glowing sentence and fading with perfect timing. We pass through these dusty trails each year, and the heavens answer with showers that arrive like annual lullabies. Perseids, Geminids, Leonids, each with its own subtle rhythm. If you've ever made a wish on a shooting star, you've practiced the oldest astronomy, paying attention and letting wonder open a door inside you. Turn to the moon now, a familiar companion, gentle and constant. Watch its phases flow, a fine silver thread, a letter D, a chalky coin, a lantern strong enough to throw shadows across fields. Its light is sunlight, softened sunlight that has touched dust and old lava plains, bounced back and draped the world with milk. The moon's pull cradles the oceans into tides and, in a way, cradles us too. When its bright face climbs your window, you can almost hear a rhythm, slow as breath, reliable as sleep. And the wanderers' planets write their own calm notes across the sky. Venus glows like a candle held close. Jupiter steadies itself with a kingly brightness, and if you peer through a small telescope, you may see its 4 major moons, little pearls in a line, changing positions night to night in a miniature ballet. Saturn appears with a restrained majesty, its rings a thin hymn around a world of pale gold. No rush, no clamor, just orbits drawn with patient ink. Near the tops of the world, and near the bottoms too, the sky sometimes sings in color. Curtains ripple green and pink, as if the night has grown translucent wings, the aurora. Charged particles stream in from the sun and meet our air. Atoms glow, and the darkness becomes a living thing. You stand under it in winter, boots crunching, breath clouding, and you feel the quiet of cold. And above that quiet, a moving light that seems to breathe with you. There are places in the cosmos where matter thins, where entire superclusters give way to great, gentle voids. Imagine drifting through one of those vast clearings, where galaxies are rare and the dark is almost perfectly deep. Solitude there is not loneliness, it is spaciousness, the universe giving itself a wide, calm room. In such places you learn that emptiness too can be generous. Beneath everything hums a background, an ancient glow stretched into microwaves, the after warmth of a young cosmos cooling enough to let light slip free. It is everywhere at once, a faint blanket cast over all of space. Knowing it's there is like discovering that the house you're resting in has a heartbeat in the walls. A soft, steady reminder that everything began warm and bright, and has been unfolding, unhurried, ever since. Planets form the way rest arrives, bit by bit. Dust collects into pebbles, pebbles into rocks, rocks into bodies that sweep the path clean as they grow. Heat sparking, surfaces softening, atmospheres gathering like sighs. Millions of years pass without any need for hurry, and out of that patience come worlds some icy and blue, some stormy and striped, some silent, stony, and ready to cradle a tiny lake or a future footstep. Gravity is the quiet law that keeps every promise. It tucks you into your mattress while it conducts galaxies in sweeping arcs. The same pull that sets tides and bends starlight is the soft insistence you feel when you choose to stay, to rest, to let thoughts settle like snow in a still globe. When you exhale, you can almost feel gravity smooth the air over you like a blanket. Remember too, the silence. Space carries no sound, no echo of flame, no rattle of stones, only the choreography of light and gravity and time. If you've ever stepped into a forest after snowfall and felt the whole world hush, the sky's silence is that, multiplied until even your worries feel embarrassed to speak. In that quiet, the mind does not need to be loud. It can simply note, I am here, I am safe, I am small, and that is peaceful. Out beyond, quasars blaze distant, powerful, and by the time their signals reach us, very gentle. Their energy has been spread thin across unthinkable distances, arriving as a faint, ancient murmur. Even the universe's most dramatic events soften with time and space, teaching us that intensity can fade into harmony. During the day, the stars are still above you, wrapped in blue. They do not leave. They wait. That constancy is a kindness. The sky is never truly empty, merely veiled. If you were to rise above the air itself, you'd see them again, steady and honest, even while the sun stands bright. What is hidden is not gone. What is quiet is not absent. The Milky Way and Andromeda drift toward each other, and in a few billion years they will overlap, swirl, and settle into a new shape. It will look dramatic if you could watch it sped up, but in real time, it is a slow waltz stars, mostly slipping past stars. Night after night, century after century, until a new, larger calm emerges. The universe is an artist who never hurries. Every stroke is patient. Between clusters, the dark grows cool close to the coldest temperature nature allows. Think of that not as harshness, but as a perfect stillness, a room kept for deep rest. In such quiet, cold, heat is precious, and every small glow, every candle star, feels like a friend. Stars live and stars rest. Small red ones sip their fuel for ages. Big blue ones burn with brief, brilliant vigor. Sun-like stars one day puff gently, shedding their outer layers into glowing shells that hang like lanterns in the dark planetary nebulae, delicate and short-lived on cosmic scales. Brief artworks, exhaled by a life well spent. The cores cooled to white dwarfs, embers that shine on in peace. From the ashes of heavier stars, new elements scatter iron for blood, oxygen for breath, carbon for softness and sweetness. We carry star stories in our cells. There is a mystery woven into the fabric of space, a pressure that urges everything to drift apart a little faster than gravity would prefer. Dark energy, we call it. A name that is really an open door. You don't need to solve it to be soothed by it. It is the universe's long, slow tide. Out, out, out. A promise that there is room to grow. For all of human history, we have looked up for direction. The North Star steadies our maps. Bright seasonal stars frame our harvests and our voyages. Even now, when satellites whisper us our coordinates, the sky remains a strong, simple compass. Look north, there is Polaris. Look east before dawn. The zodiac lifts another bright traveler. Guidance doesn't have to be loud to be true. Each observation we make, each sketch of a moon, each exposure of a distant cluster, each faint line in a spectrum is a page gently turned. The universe is a book with no last chapter, and somehow that is the most restful thought. You are not late to understanding. You are simply here for your part of the reading, and that is enough. Cosmic rays drift through all this, a fine, almost transparent rain of particles from faraway fireworks. They pass largely unnoticed, reminders that even in stillness there is a subtle exchange with the wider world. Quiet does not mean nothing is happening. Quiet can mean everything is happening without asking anything from you. Time, on these scales, is soft. It stretches, it flows, it forgives. Stars measure it in millions of years, galaxies in billions. When you hold your life against that canvas, worries shrink to manageable size. There is space to breathe. There is permission to rest. Lift your eyes once more and let them fill with starlight. See how the sky does not demand, it only offers. The longer you look, the more it gives faint clusters at the edge of vision. A dark lane you hadn't noticed, a slow satellite crossing like a moving punctuation mark. If your thoughts begin to wander, let them. If your breath slows, let it. If sleep approaches like a tide, welcome it. As you lie back under this wide, serene ceiling, remember, you are built from ancient light and cooled fire, from the dust of old suns and the water of wandering comets. The laws that hold galaxies together hold you together, gently and without fail. You are not separate from the night. You are a chapter of it. Let the darkness now be a cradle. Let gravity tuck the blankets. Let the moon stand guard at your window, and let the stars hum their silent melody, each one a distant lamp kept lit for you. There is nothing you must solve, nothing you must fix, nowhere else you need to be. The universe has been unfolding for eons without hurry, and tonight it invites you to practice the same grace. Breathe in and out. Feel the floor steady beneath you, the air cool on your skin, the quiet curve of your own pulse. With every gentle breath, the sky seems closer, as if leaning down to listen. Allow yourself to drift. The constellations will keep watch, the planets will move on their patient paths, and the river of the Milky Way will flow on, low and silver, until morning. Thank you for wandering with me across this calm, lantern-lit ocean. May your sleep be deep and unbroken, your dreams spacious and bright. Until we meet again beneath the quiet stars, Keep looking up. Keep your heart open to wonder. And rest, knowing the universe holds you softly in its endless night. Okay, let's go to the next story. Close your eyes if you like, or keep them softly open. Let them fall into the gentle half-light, where room and sky breathe together. Breathe once, slowly, as if inhaling a secret the universe has been whispering for billions of years. Breathe out, release the day, like a small stone dropped into a wide, patient pond. Tonight we will walk, softly and carefully, along the edges of wonder. Imagine first a single point of light, far beyond the reach of your fingertips. It hangs in the vast blue-black, a patient ember in the dark. That light is an ancient letter, written in photons and carried for eons across loneliness and time. Each photon is a tiny messenger telling a story of clouds collapsing, of pressure building, of eventual fire. It tells us how a star was born. We begin in a nursery, not of cradles and lullabies, but of dust and quiet gravity. In these vast stellar nurseries, clouds of hydrogen breathe and sigh. They swirl and settle, a slow, graceful choreography. Regions within them grow heavier, tiny seeds of density that call to each other. Gravity, subtle and relentless, draws them closer until warmth blooms in the heart of a contracting cloud. At first, there is only the hush of atoms colliding, but then the hush becomes a murmur, and the murmur a steady hum, the birth heartbeat of a star. Picture that newborn star like a candle cupped against a blizzard, fragile yet defiant. It begins its long work of turning matter into light, forging heavier elements in its crucible. Over millions or billions of years, it is both creator and instrument, carbon, nitrogen, oxygen. These are not gifts dropped from nowhere. They are the labor of stars, the slow alchemy that stitched the periodic table into patterns that would one day be read by biology. Drift now to the patient geometry of planets. The protoplanetary disk that surrounds a young star is a slow-turning carousel. Dust grains stick like shy dancers, finding partners. Pebbles accumulate to rocks, rocks to boulders, and boulders, by a kind of stubborn fortune, become worlds. Each planet falls into its lane, some near and scorched, others distant, wrapped in the deep sleep of frozen gases. Some catch thick atmospheres and wear them like robes. Others are bare, their scarred surfaces reading like old maps. Listen. The language of geology speaks in storms and tides, in continents wandering on oceans of rock, in the patient corrosion of winds. On some worlds, water pools and weights rivers tracing the skin of the planet, oceans breathing with the slow rhythm of tides. Where chemistry and liquid meet, curiosity becomes possible. Where energy is steady and ingredients meet for long enough, chemistry can begin to take the first timid steps toward biology. Life, when it appears, is not an announcement so much as a very quiet persistence. It is the universe learning to know itself through rearranged atoms and the improbable poetry of replication. Let your mind stroll now beyond the pale neighborhood of a single star to the wider assemblies, binary stars that spin around each other in an intimate conversation. Systems where planets chase one another in complex arcs, moons that steal the stage and then return it. Imagine a night sky from the surface of a world that circles two suns. Dawn here and dusk there, shadows overlaying and unraveling, as if the universe were practicing a gentle illusion. Or imagine a planet where the seasons stretch for centuries, and an entire civilization learns patience from a slow, wandering orbit. We can come closer, closer than even the crescent of a moon, and meet comets. Comets are wayfarers, icy, ancient, carrying the scent of the outer reaches. When they approach a star, heat teases their frozen past into jets of dust and gas. creating a tale that points away, like a memory streaming behind a moving soul. Some comets have visited the young Earth, delivering water and organic molecules, small serendipitous couriers, possibly responsible for nudging chemistry toward life. They are reminders of how the universe keeps its treasures in remote vaults until the right moment. Now, allow the scene to widen. The galaxy is not a static painting, but a slow-turning ocean of stars. Our Milky Way is a disk of countless lights, an elegant swirl observed edge-on as a delicate line of soft brightness, or seen from within as a band of spilled sugar across the night. The galaxy's spirals are arms roots of ongoing formation, places where gas is funneled, compressed, and nudged into new generations of stars. At the center sits a quiet storm, a supermassive black hole, not a hungry villain in a storybook sense, but a sculptor whose gravity molds the dance of millions of suns. Black holes are not only endings, they are thresholds. Their gravity warps both space and time, bowing light as if the fabric of reality were a soft sheet. When a black hole feeds, it can make light brighter than entire galaxies, an irony that reminds us how extremes are sometimes necessary to create beauty. Around many black holes, matter swirls in a furious incandescent maelstrom, jets of particles leaping outward like fountains that pierce the dark. The mathematics that describe such objects are both austere and wondrous, a vocabulary where infinity and smallness meet. Think for a moment about the scales we talk about. Atoms to planets, planets to galaxies, galaxies to clusters, and then to the cosmic web. Between galaxy clusters, filaments of gas and dark matter trace a pattern like frost on a window. Dark matter, an invisible presence, holds the web taut, a scaffolding without which galaxies would not gather. Though we cannot see it with our eyes, we sense its gravity by watching things move as if pulled by invisible hands. There is humility in that. Much of what shapes the universe is one step removed from our senses, and yet is no less real. Time itself carries a story. The cosmic microwave background is a faint afterglow of the universe's earliest visible chapter, a whisper from when the universe was just a few 100,000 years old. It is cool now, a mere 2.7 degrees above absolute zero. But it is a map, a photograph of the infant cosmos, with tiny fluctuations that seeded everything that followed. To hold that image in your mind is to understand that even the largest things started as the smallest differences, tiniest ripples that eventually grew into vast structures. Picture the cosmic timeline like an old patient book. The first pages are quick and feverish. Inflation, a sudden stretching that smoothed space like kneading dough. Then atoms formed, light untangled from matter, and a dark age fell long and silent until the first stars lit tiny lamps that pushed back the gloom. Galaxies assembled, merged, and spun off new generations of stars. Planets formed from the debris left in the aftermath of these cosmic negotiations. In this unfolding, humanity appears very late, an afterthought in the second-to-last paragraph. And yet, in the human mind, a universe of meaning ignites. Let us visit one small chapter in which curiosity itself evolves. Consciousness. Somewhere in the long history of Earth, early cells invented a trick replication with variation, and then, over eons, nervous systems learned to sense. Brains are storytellers. They knit signals into patterns and name them. Consciousness is an emergent candle, lit by complexity, sustained by exchange, and flickering with memory. It is in this candlelight that we ask why and how, and in asking, we create narratives that fold the cosmos back onto itself. Imagine now an observer standing at the edge of a cliff beneath a trembling aurora, or a night watchman on a ship gazing at the stars smeared with meteor trails. The same processes that cook the insides of stars also create the copper in your phone camera. the oxygen in your lungs, the metal in a bridge, the calcium in a tooth. These are all descendants of ancient stellar furnaces. There is a soft, almost ineffable intimacy in that. The universe gave us, over long patience, the very elements that make selfhood possible. We can also sense the fragility of home. A planet's atmosphere is a delicate blanket. It can warm gently under a benevolent star and sustain richness, or it can be stripped away by flares and winds, leaving raw stone. Small differences in chemistry, rotation, or magnetic shields can mean the difference between a world teeming with potential and one that remains mute and barren. The history of planets is a study in chance and contingency. Local weather, global catastrophes, rare impacts, the ephemeral vicissitudes that shape long-term trajectories. Turn your attention now to communication across distances. Light is a faithful courier, but it travels at an upper limit. Signals sent across interstellar space take years, centuries, or millennia to arrive. Even at light speed, messages are delayed by the tyranny of scale. If someone on a planet 500 light-years away shouts into the dark, their voice is a letter that will arrive here only 5 centuries from now. That slowness teaches humility and patience to any mind that imagines sending greetings. Consider how we listen. Our instruments extend senses. Radio telescopes tune to the faint hum of hydrogen between galaxies. Spectrometers unweave starlight into colors and reveal composition like detectives reading fingerprints. When we find a spectrum with telltale signatures, water, methane, oxygen, we do a kind of forensic archaeology across time and space. We cannot visit many of these places. Instead, we learn to translate the light they send, to read whispers of chemistry and motion, and to infer landscapes from small, indirect clues. There is also the poetry of scale in motion. Galaxies collide not as catastrophic bangs, but as slow, majestic ballets that stretch across millions of years. When 2 galaxies meet, their stars mostly pass like ghosts, but their gas clouds crash and ignite bursts of star formation, new lights born from the turbulence. In the far future, our Milky Way will kiss Andromeda in such a dance, a slow merging that will change the map of the night, but will not necessarily be an apocalypse for individual systems. Time grants the universe a kind of patience we cannot fully fathom. Let us touch, briefly, on endings and beginnings folded into one. Stars of certain masses end their lives with a final flourish. They swell into red giants and drop outer shells that smell of future gardens, planetary nebulae, whose glowing rings are nothing less than stellar farewell notes. Some massive stars go out as supernovae. They explode with a brightness that can outshine entire galaxies for a while, scattering heavy elements into the void. These explosions are fertile. They pepper the interstellar medium with the seeds for future planets and life. The iron in your blood was once inside a star that died in fire. And then there are rarer endpoints. Neutron stars compacted into the mass of the sun, but squeezed into a city-sized sphere. Spinning so fast, they sweep beams of radiation across space like distant lighthouses. When 2 neutron stars merge, they ring the cosmos in gravitational waves, ripples in space-time itself. These ripples are like the faint tremors of a gigantic bell, small on our scales but monumental on a cosmic ledger. We have learned to hear them, to listen to space-time, and in doing so, we have opened a new sense. Now imagine, for a slow moment, a distant sea, where bioluminescent organisms light up like stars in miniature. Each little flash a private signal, an invitation, a memory. On some exoplanets, life, if present, might glow under active skies, or it could be hidden within subsurface oceans under a frozen crust. Moons like Europa or Enceladus in our own system hide oceans beneath icy shells. There is something deeply consoling about water kept warm and dark for aeons, about the patient possibility contained in enclosed seas. If life exists elsewhere, perhaps it is quiet, tucked into corners where chemistry can be steady and undisturbed. Let your thoughts wander to civilizations, which may exist as brief candle flares along a long timeline. The technological curve of a species could rise quickly and fade due to self-made or natural disasters. It could also plateau into a sustainable, quiet stewardship. We do not know. We only know our own species' late curiosity and the sudden brightness of our signals leaking into space like dandelion seeds in a wind. Radio and light-based signals expand outward, thin and faint, like footprints in powder snow, detectable at a distance if someone is both listening and clever enough. There is comfort here too. Loneliness on cosmic scales does not mean emptiness. The cosmos is full of patient processes. Life and intelligence, if rare, may be spread like scattered campfires across an enormous plain. And perhaps the act of knowing, of looking, measuring, imagining, binds us into a community with the rest of the cosmos. In studying stars and particles, in parsing spectra and building telescopes, we cast ourselves as students in a grand school. As you listen, either with your ears or with your mind, feel the rhythm of the universe as a lullaby of durations. A human lifetime is a handful of breaths compared to geological ages, and geological ages are a blink beside cosmic epochs. Yet within a single heartbeat, we can hold awe, grief, curiosity, and love. These human scales are not failures of perspective. They are the universe experiencing itself in a compact, fervent form. Now, imagine returning home, descending slowly from the bright cathedral of the galaxy, through the still, cold arms of interstellar space, past the commuter belts of comets, past the warm glow of a friendly star. You approach a tiny blue planet, the home you know. From orbit, continents are soft petals and storms curl like calligraphy. Cities are small nodes of light, patterns of habit and story woven together. On one such night, someone looks up with an ancient sort of yearning, recognizing in the dots above both estrangement and kinship. To end, consider this quiet, generous truth. You are made from the same elements as the stars, and those elements have traveled cosmic distances to arrive, patient as rain, into your bones. Your thoughts are shaped by molecules forged in fire. Your curiosity is a continuation, an echo of the processes that stoke stars and fold galaxies. In that sense, the cosmos is not merely something outside, it is an inheritance and a companion. So let tonight be ordinary and extraordinary at once. Let the soft knowledge of distant light settle in like warm dust. If sleep comes, let it be gentle, like the slow drift of an orbit. If your mind wanders, let it wander along the spiral arms, where new stars are still being hatched. Tomorrow, when you open your eyes, the world will feel familiar and newly strange, and you will carry with you the hush of long distances, the patient grammar of the universe, and finally, a closing image. A small child on the threshold of a house, holding a lantern. The child is not yet sure what stories will come, but they are learning to read the sky. The lantern casts a gentle circle of light, and, within it, the child's face is full of person-sized astonishment. Outside that circle unfolds a darkness so wide and generous that it invites stories rather than denies them. Walk now into that small, safe pool of light. Breathe, and let the vastness sing you slowly into rest. Good night.